Let's look at an example dealing with particle motion. This is an important question because there are a lot of links here to AP, both multiple choice and free response questions. So it goes like this. A particle moves along a line so that its position at any time t 0 or greater is given by the function s of t is equal to t squared minus 4t plus 3. So this is the position function, where s is measured in meters and t is measured in seconds. We want to do a few things. We want to find the displacement of the particle during the first 2 seconds. We want to find its average velocity during the first 4. We want to find both the instantaneous velocity and the acceleration at time 4 seconds. And then finally, we want to describe the motion of the particle and at what value or values of t does the particle change direction. So I graphed a Desmos graph of this scenario. We see the particle here in red. I did have to change the name of the function from s to q because we've used s before. I changed time from t to m because we've used t before. So we can watch this motion or watch the motion of this particle as we move time greater. So this particle starts at position, looks like 3. It moves backwards for some time and then changes direction and moves forward on and on to the right. So let's watch it one more time. Here it is in full motion, and it keeps moving positive or towards the right from then on. So with that in mind, let's get back to our notes and answer the first question. We want to find the displacement of the particle during the first 2 seconds. So remember that displacement is just a difference of 2 positions. So in this case, we want the position at time 2, and we want to subtract our position at time 0. So let's find those 2 positions first. So s of 2 will be 2 squared minus 4 times 2 plus 3. So that's 4 minus 8 plus 3. So that's negative 4 plus 3 for a final position of negative 1. The position at time 0, our graph made it look like it was at 3, but let's make sure. S of 0 would be 0 squared minus 4 times 0 plus 3, and indeed, that is 3. So if we have negative 1 minus 3, that means our displacement. So the total movement of that particle, or the difference between positions, is negative 4. And in this case, we're in meters. So we can say subtract 4 meters. Let's go to part B. Find the average velocity of the particle during the first 4 seconds. So average velocity is a change in displacement over a change in time, or displacement. Actually, it's a change in position. I called it displacement. Let's call this delta S, change in position over change in time. In other words, it's displacement. Let's try to spell that a little bit better. Displacement over time traveled. So in this case, first 4 seconds, we're going to say s of 4 minus s of 0, and then over the time traveled, that would be 4 seconds. Second forward minus second 0 is 4. So what's s of 4? Let's see. That's going to be 4 squared is 16 minus 4 times 4 is 16. So 0 plus 3, so 3 there, minus the position at time 0 is 3. We already found that out in part A. And then this is over 4. So 3 minus 3 is 0. 0 over 4 is 0. And average velocity, that's a rate. So in this case, we're going to be in meters per second. So our average velocity, 0 meters per second. Let's go to part C. Find the instantaneous velocity of the particle when t is equal to 4, or at time 4 seconds. We know instantaneous velocity is the derivative of position. So we want v of t, which is also s prime of t. And this is, well, by the power rule, 2t minus 4. So what is that velocity when time is equal to 4? In other words, what is v of 4? That's going to be 2 times 4 minus 4, and that's 8 minus 4. So our velocity here is going to be 4, and that's a rate. It's in meters per second. So that's part C. Let's move to part D. What's the acceleration of the particle when t is 4? So we know acceleration is the derivative of velocity, or the second derivative of position. So s of t is this. We're going to look at s prime first, and we just found that out in part C. So this is 2t minus 4. And then the acceleration is the second derivative of position, which is just 2. So the acceleration at time 4 seconds, a of 4, is going to be 2. Actually, it would have been 2 no matter when or at what time, because it's a constant function. And this is acceleration, so that's going to be in meters per second squared, or meters per second per second. All right, we move on to part E. Describe the motion of the particle. At what value or values of t does the particle change direction? Well, we already saw from the Desmos graph that we believe this function, or this particle, starts to move backwards and then moves forward on after that. So my question is, I guess, when does it change position? Well, it's going to change position at that moment that the velocity is equal to 0. So let's take a look at that. The velocity function is the derivative of position. So at this moment, it's going to be 2t minus 4. When is that equal to 0? In other words, when does it change from negative to positive, or positive to negative? In this case, that's going to be at t equals 2. So we change position at time equals 2. And if you take a look at the graph to the right, the red line is the velocity graph, v of t, which is 2t minus 4. And if you take a look at that line, it is below the x-axis all the way until time equals 2. So it's below the x-axis, or negative values of velocity below the, to the left of time equals 2. It's above the axis to the right. So that's telling me if velocity is negative before time equals 2, we're moving backwards. If velocity is positive to the right of time equals 2, we're moving forward. So we move backward, or the particle moves backwards from time equals 0 to time equals 2, and forward from time equals 2 on. And that is because, well, t equals 2 is the only place that we changed position. So that's the end of our question on particle motion, and that sums up the video series for now.